Okay, we'll start our kind of homework Kai, who's only a high school student. Let's find out. Good. And his topic is Piuma Paiwan stress in directional evaluation. Let's welcome our speaker.
Yes. So, like I said, I'm just a high schooler, so I'm really anything but confident right there, and I don't disappoint you.
Pretty nice.
Okay, so I'm going to talk about this computational linguistics about Piuma Paiwan in Python. And first, I'll talk about the language. It's a formative language, and Piuma Paiwan is one of the dialect of the Paiwan language, which is Taiwanese native language, and it's also an unsafe language, as according to UNESCO. And for the stress features, so first it's a right-aligned trochee system, and it's penultimate syllable with stress with the coda consonants non-direct. But if the penult nucleus is a schwa, which is the upside down E as its vowel, the schwa will undergo a reduction, and the stress will shift from penult to the final syllable with its vowel lengthen. And in this case, the schwa has a total of three kind of variants and location. And it can be a non-moraic, bimoraic, or monomoraic schwa, which would depend on where in the foot is. So here's the data that demonstrates that example. So you can see for the two syllables, it's a simple trochee. And for words with three syllables, it's a little trochee from the right direction. So you can see generally the penult syllable is stressed. But if it's schwa, like in the C case at the bottom, the stress will shift and the vowel is lengthened, marked with the colon. And I'm going to talk about the two ways of modeling the optimal stress patterns, or like how the words should be pronounced given only the letters. So there's harmonic serialism and optimality theory. So before talking about those two, there is violation or the constraint on the stress patterns. It's just a given rule, and we always prefer patterns that violate less, or if they have to violate anyways, we want them to violate the rules on a less significant position. And these are all the violations considered. One thing to say is if you're using directional evaluation, you don't actually need this many rules, but the one I modeled was OT or optimality theory, so these are all the ones I coded. There's a total of 13 rules. So start from trochee and ion, and then parsing and non-final, which is for the feature of Paiwan language. And HD, balance trochee, right foot, and then the max mu and stress schwa is specifically for schwa and long vowels and moraic schwa and non-moraic foot and clutch. So the concept difference between harmonic serialism and optimality theory is one cares about the location of violation, which is, I said, if we have to violate, we want to violate on a less significant position. And it has the direction included in the rule. So today I'm evaluating the trochee rule and right. If right word, then so I start from the left to right, and the earlier I see the violation, the more significant it will be. So a violation on the left will be more significant and make it less goal. And optimality theory, on the other hand, only cares about the number of violation. So, like if for the same rule a pattern violates on two locations, then it's always preferred over another pattern which violates on three locations. And the difference when it comes to actually coding it is that harmonic serialism is an iterative improvement, while OT is an exhaustive selection. So for the iteration, that uh, according to the direction of the first rule, we parse one foot for each iteration, then we select the best candidate, and then we parse again. Uh, we consider the candidates with another parse foot plus the best candidate from the last round together, and then get the new best candidate until we reach the end. While OT is that we list all the possibilities together and see which is the best. Now, this is why one is called directional and one is parallel, because serialism, the direction shows, so first, when the significance of the validation location is its direction, while OT is that we consider all possibilities equally. So that at the same time, so that's the parallel evaluation. And the result difference is that uh, the best candidate for OT, it may be eliminated during the rounds of directional evaluation, while the best candidate from DHS may be less preferable. This is because of a look ahead effect that OT has. Is that for for DHS, each time we only parse a foot and then we select our candidate. But there may be one there may be one possibility that is a continuation of a less preferable. But as it has more parse foot, it becomes more preferable than the best candidate DHS gives. So why prefer DHS? Even though it may be harder to code, is that so it looks for a harmonic improvement, which makes it more similar to how they actually pronounce the word. So the result may be more authentic, and also there's less unexpectancy. So there wouldn't be like a possibility that says if you parse three more feet, then it suddenly becomes its violation becomes less than what we know as the best candidate. Also, it reduced the required constraints, like I said when I was introducing the violation. For example, the feed binary uh, violation, it was to ensure a binary feed. If we implement, if we're using OT and simply go through all the rules, this would be one of them. But if we use directional evaluation, after we do choki, ion, or parse together, whether this rule exists or not will not affect the results. And also, it reduces the risk of overfitting and overlooking constraints because, like the same, if there are rules, there are minor rules like this that can be subsumed under the general rules like choki and ion. But if we're using OT, which may require all these minor rules, there may be rules that we overlook or we have to specifically list out, like say, add a violation if the second syllable is not strict. So that will cause an overfitting in the algorithm. And also, if we didn't find it, then it will produce an off result. So the significance of directional evaluation in Paiwan is that it was intended as a method intended for quantity and sensitive language, but Piuma Paiwan meanwhile is a quantity sensitive language. So if it succeeds, then it will show scalability and suitability of harmonic serialism. And what I did in my program is I gave direction to the OT. So how I did it is that I weighed the violations. So when I count the violation, I multiply them by the index base weight, or say that uh, so the weight is uh, calculated as 2 to the power of its, depending on where it is. So the earlier violation is always punished over later violations. So for example, the at the bottom line where uh, I have two patterns of a 4-syllable pattern, where one marks a violation and zero marks no violation. Um, you can see even well the first evaluating on left to right, the 1000 is punished more than 0111, even though it has less, because it's on a more significant location. So the difference between that and DHS is that DHS again is iterative. And what I did, even though I added weight, is that it's still exhaustive. So it's still more similar to POT. But if this succeeds, it will make the algorithm more systematic and more efficient to make. And the potential improvement of my program is that to identify and discard redundant constraints, which is, like I said, there are violations possibly subsumed under other violations. And before I actually run the tech code, I can find them and just take them out of the process to increase efficiency. Now, gonna show some of our actual code. So this is technical. I use the object-oriented programming for this. So I name all the syllables into an object so that they have their attributes, and then make the series of algorithms to make the stress patterns and evaluate their violation score. Like the higher it is, the more violations it makes, and it's this variable. So this is a demonstration input, which I only give the letters. And depending on the rules I gave, it prints out the result pattern. It's a trophy, but parsing the food with the first syllable stress. And result from the program is that they mostly match, which shows a good sign, but still, for the key exceptions that did not work for OT, it also did not work for OT with direction. With like the one shown here, like look ahead, in fact, it still exists. What this shows is that OT is an unsuitable approach compared to DHS. It's still superior in terms of accuracy, even though might not in efficiency. So my attempt to increase its efficiency and simplicity did not work. Directional evaluation did not prevent OT from over-generating the untested cases. And if you're interested in actual code, I put on get seriously. And that's the end of the presentation.
Okay, thank you. We have plenty of time. I wonder if anyone would like to ask questions. Okay.